Okay, so the problem is asking us to find dy over dx by implicit differentiation. The first thing we're going to do is use the product rule. On the left side in the bracket, we have e to the x cosine y. So we're going to break those up into f of x and g of x. We will find the term and its derivative. So we have f of x equals e to the power of x, and g of x is cosine y. Underneath, we find the derivative of each f of x equals e to the x. Remember, the derivative of e to the x is always e to the x. The derivative of cosine y is a rule we know from trigonometry, which is negative sine y. Because we are looking for dy over dx, this is all multiplied by dy over dx on the right side. So now the product rule says we are essentially cross-multiplying each term in the derivative of the other term. We have f of x, which is e to the x, times the derivative g, which is parentheses negative sine y, times dy, close parentheses, plus the derivative of f, which is e to the x, times g, which is cosine y. Now the left side is done. The right side is easy because we know the derivative of the term x is 1 and the derivative of term y is 1, also times dy over dx. So now if we distribute our terms to the left, we have negative e to the x sine y dy over x plus e to e to the x cosine y equals 1 plus dy over dx on the right. We need to solve for dy x, so we have to get it on one side, so we subtract the 1 dyx from the right and the left. And we subtract e to the x cosine y from the left and the right, which leaves us with negative e to the x sine y dy over dx minus 1 dy over dx equals 1 minus e to the x cosine y. You can see that we can use the factor out. We see that we can factor out dy over dx from both terms on the left, which leaves us with dy dx times negative e to the x sine y minus 1 equal 1 minus e to the x cosine y. Now we have to divide both sides of the terms in parentheses on the left to get dy dx alone. So dy over dx equals 1 minus e to the x cosine y over negative e to the x sine y minus 1. And that is your answer. Thank you very much.